NEC 550 addresses the electrical requirements for manufactured buildings, which includes portable classrooms used for long-term occupancy. One crucial aspect is grounding. The portable classroom needs a separate grounding electrode system, typically involving its own ground rods. This is vital because it's a separate structure without any common metallic paths connecting it to the main service ground. An equipment grounding conductor, or EG, must connect to this grounding electrode system. Its size should adhere to Article 250 of the NEC. It is important to avoid having a neutral to ground bond within the portable classroom's electrical panel. Neutral to ground bonds are permissible only at the service entrance, not in subpanels. Treating a portable classroom like a mobile home isn't accurate because mobile homes have distinct grounding setups. In this case, the described setup is not a mobile home configuration. Ensure that the portable classroom is firmly anchored to the ground to avoid movement caused by wind or other factors. When planning the electrical service and grounding, carefully consider the electrical load of the classroom. Adequate ventilation is essential to prevent moisture and condensation buildup. Based on this, the installation seems compliant with the NEC, assuming that the separate grounding electrode system and the equipment grounding conductor are installed as necessary. The inspector's worries about treating the classroom like a mobile home don't apply here. Regarding the grounding requirements in more detail, firstly, a grounding electrode system is required at the portable classroom. This usually involves driving ground rods into the earth near the structure. The purpose of these rods is to provide a low impedance path to ground for fault currents. Secondly, the equipment grounding conductor, or EC, is a critical safety component. It connects the metal parts of electrical equipment, such as junction boxes, conduit, and appliance chassis, back to the grounding electrode system. The EGC ensures that if a fault occurs, such as a wire accidentally touching a metal enclosure, the fault current will flow back to the source and trip the circuit breaker, quickly de-energizing the circuit and preventing electrical shock. Thirdly, the sizing of the equipment grounding conductor is determined by Article 250 of the NEC and is based on the size of the overcurrent protection device, such as a circuit breaker, protecting the circuit. Larger circuits require larger equipment grounding conductors to safely handle the fault current. Fourthly, the absence of a neutral to ground bond in the subpanel is a key safety requirement. The neutral conductor should only be bonded to ground at the service entrance. If a neutral to ground bond exists in the subpanel, it can create a parallel path for neutral current, which can lead to circulating currents and potentially create dangerous voltage on metal enclosures. Fifthly, proper anchoring of the portable classroom is important to ensure that the grounding system remains intact. If the structure moves, it can strain or break the grounding conductors, compromising the safety of the installation. Sixthly, assessing the electrical load of the portable classroom involves calculating the total amount of power that will be used by all of the electrical devices and equipment in the structure. This includes lighting, receptacles, heating and cooling equipment, and any other appliances. The electrical service and grounding system must be sized appropriately to handle this load. Seventhly, proper ventilation is necessary to prevent the buildup of moisture and condensation. Moisture can cause corrosion of electrical components and increase the risk of electrical shock. Ventilation helps to keep the inside of the structure dry and safe. Eighthly, in addition to the ground rods, the grounding electrode system may also include other electrodes, such as a metal underground water pipe or ground ring. These additional electrodes help to further reduce the impedance of the grounding system. Ninthly, the connections to the grounding electrodes must be made using approved methods and materials. Typically, this involves using exothermic welding or listed grounding connectors. The connections must be mechanically strong and corrosion resistant to ensure a reliable ground fault path. Tenthly, regular inspection and testing of the grounding system is important to ensure that it remains effective over time. This includes visually inspecting the grounding conductors and connections for signs of damage or corrosion, as well as testing the impedance of the grounding system to ensure that it is within acceptable limit. Another item is that NEC 550 specifically addresses the requirements for manufactured homes, which are different from site-built homes. These requirements are designed to ensure the safety of occupants in these types of structures. An important distinction to make is that the inspector's concern about treating the portable classroom like a mobile home is based on the fact that mobile homes often have their own separate grounding requirements. However, in this case, the portable classroom is not wired like a mobile home, so these specific requirements do not apply. An additional point is that the service is located at the pole, and the portable classroom is a separate structure with no other common metallic paths. This is an important factor in determining the grounding requirements. Because the two structures are not interconnected by any metallic paths, a separate grounding electrode system is required at each structure. A further point is that the grounding electrode system at the portable classroom should be bonded to any metal enclosures or equipment in the structure. This includes metal conduit, junction boxes, and appliance chassis. Bonding these metal parts together ensures that they are all at the same potential, which reduces the risk of electrical shock. Another element to consider is that the size of the grounding electrode conductor, which connects the grounding electrode system to the electrical panel, must be sized in accordance with Article 250 of the NEC. The size of the grounding electrode conductor is based on the size of the service entrance conductors. Something else to remember is that the grounding electrode system should be installed as close as possible to the portable classroom. This minimizes the length of the grounding electrode conductor, which helps to reduce the impedance of the grounding system. Another aspect to consider is that the NEC requires that the grounding electrode system be accessible for inspection and testing. This means that the ground rods should be located in an area where they can be easily inspected and tested. In addition, the NEC requires that the grounding electrode system be protected from physical damage. This can be accomplished by installing the ground rods in a protected location or by using a ground rod cover. Another detail is that when driving ground rods, it is important to ensure that they are driven deep enough into the earth to make good contact with the soil. The NEC requires that ground rods be driven at least 8 feet into the earth. Also, if the soil is rocky or sandy, it may be necessary to use longer ground rods to achieve the required depth. You should also know that in addition to the grounding requirements, the NEC also has specific requirements for bonding in manufactured buildings. Bonding is the process of connecting together all of the metal parts of the electrical system to ensure that they are all at the same potential. Another detail is that the bonding requirements in NEC 550 are similar to the bonding requirements in other parts of the NEC. However, there are some specific requirements that apply only to manufactured buildings. And it is good to remember that one of the most important bonding requirements is that the neutral conductor must be bonded to the metal frame of the manufactured building at the service entrance. This bond is intended to prevent voltage from developing on the metal frame, which could create a shock hazard. Furthermore, all metal parts of the electrical system, including conduit, junction boxes, and appliance chassis, must be bonded together. This can be accomplished by using bonding jumpers or by using metal conduit fittings that are listed for bonding. Another bonding requirement is that the water piping system must be bonded to the electrical system. This is intended to prevent the water pipes from becoming energized, which could create a shock hazard. In addition to the grounding and bonding requirements, the NEC also has specific requirements for wiring methods in manufactured buildings. Wiring methods refer to the types of wiring that are allowed to be used in the building. And one of the most common wiring methods used in manufactured buildings is non-metallic sheath cable, also known as Romex. Romex is a type of cable that consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Romex is relatively inexpensive and easy to install, which makes it a popular choice for manufactured buildings. However, Romex is not allowed to be used in all locations. For example, Romex is not allowed to be used in wet or damp locations such as bathrooms or kitchens. In these locations, other wiring methods such as conduit must be used. Another common wiring method used in manufactured buildings is conduit. Conduit is a metal or plastic pipe that is used to protect electrical wiring. Conduit is more expensive and more difficult to install than Romex, but it provides better protection for the wiring. Conduit is required to be used in certain locations, such as in areas where the wiring is subject to physical damage. In addition to the wiring method requirements, the NEC also has specific requirements for overcurrent protection in manufactured buildings. Overcurrent protection refers to the use of circuit breakers or fuses to protect electrical circuits from overloads and short circuits. The NEC requires that all electrical circuits in manufactured buildings be protected by overcurrent devices. The size of the overcurrent device must be appropriate for the size of the circuit. For example, a 15-amp circuit should be protected by a 15-amp circuit breaker or fuse. In addition to the overcurrent protection requirements, the NEC also has specific requirements for ground fault circuit interrupters, or GFCIs, in manufactured buildings. GFCIs are devices that are designed to protect people from electrical shock. GFCIs work by monitoring the current flowing in a circuit. If the current flowing out of the circuit differs from the current flowing back into the circuit by more than a few milliamperes, the GFCI will trip and de-energize the circuit. The NEC requires that GFCIs be installed in certain locations in manufactured buildings, such as in bathrooms, kitchens, and outdoor areas. In addition to the requirements for grounding, bonding, wiring methods, overcurrent protection, and GFCIs, the NEC also has specific requirements for lighting in manufactured buildings. The NEC requires that all manufactured buildings have adequate lighting for the intended use of the building. The amount of lighting required depends on the size and type of the building. For example, a classroom will require more lighting than a storage room. In addition to the general lighting requirements, the NEC also has specific requirements for emergency lighting in manufactured buildings. Emergency lighting is lighting that is designed to provide illumination in the event of a power outage. The NEC requires that emergency lighting be installed in certain locations in manufactured buildings, such as in exit corridors and stairwells. Beyond the electrical aspects, it is important to ensure that the classroom meets all applicable built-in codes and regulations. This includes requirements for fire safety, accessibility, and structural integrity. Working with qualified professionals, such as electricians and building inspectors, can help to ensure that the installation is safe and compliant. Remember that local codes and regulations may vary, so it is essential to consult with local authorities to ensure compliance.